Hey everyone, today we're going to be talking about parabolas. You have seen parabolas before. Way back when you first learned about quadratics, you saw parabolas. And you typically saw them in one of these two formats, probably the top one more often than the bottom. The top one's a general form, the bottom is vertex form. But by definition, a parabola is the set of all points in a plane that are equidistant from a fixed line, called the directrix, and a fixed point called the focus that is not on the line. And that sounds like a lot of talk, but I'll go through that definition in a minute. But let's just do a quick review of parabolas, right? We know that the vertex is at HK. We know that if A is positive, it opens up. If A is negative, it opens down. And the axis of symmetry is x equals negative b over 2a. But let's talk about this whole idea of this set of all points with a equidistant from a fixed point and the directrix and all of that. Again, we can have parabolas that open up or down, or we can have parabolas that open left or right. And you'll see the equations for both of them up here. Now, we're not used to seeing the equations written like this. You're used to seeing it written something like y is equal to x squared, right? So here we kind of flip it around. The term that's squared is what we put first when we're dealing with parabolas, okay, for our purposes here. Now, a couple things about this picture. Your focus is always on your axis of symmetry. So you'll see here, this is your focus. And the distance from the vertex to that focus is p. Okay? So when we have parabola with a vertex at the origin, then if the parabola opens sideways, that focus is at p0. Okay, the focus is at p0. Now, you also have a line. That line is called the directrix. And that line is a distance p from the vertex. Okay, so the vertex basically is the midpoint between the directrix and the focus, if you want to think of it that way. Now, all that definition was saying is I can take any point. I can take any point on my parabola, and that point is going to be equidistant from that focus and from that directrix. And remember, when you're measuring the distance from a point to a line, you always measure the perpendicular distance. Okay, but this distance here is equal to this distance here, and that's just the definition of what a parabola is. Again, we can have a parabola that opens sideways, or we can have a parabola that opens up or down. Now, in this particular form, right, this would be a parabola that opens to the right. If you had a parabola that opened to the left, still centered at the origin, then your p-value here would be negative. So this would be negative p0, and then your directrix would be over here, and the equation of your directrix would be x is equal to positive p. Okay? Similarly, over here, you can have a parabola that opens down, and if your parabola opens down, then your focus is here. That would be at 0, negative p, and your directrix would be up here, and that equation would be y is equal to positive p. Okay? So your directrix is always on the side of the parabola where it doesn't open. So your directrix will never intersect with your parabola. Okay, so that's just a little bit of general information about it. We're going to start talking about the equations, how we generate the equations, and things like that. So in the next part of your notes, it says find the focus and directrix of the parabola y squared equals 12x, and then it says to graph the parabola. Previously, you were used to graphing the parabola by getting the vertex and then plotting a bunch of points and then sketching out the graph. So we're going to approach it a little bit differently. Remember, the general form of our equation is y equals 4px. Okay, so y squared equals 4px. And so here I have y squared is equal to 12x. And so we can see here that 4p is equal to 12, which means that P is equal to 3. Okay, so I know that my parabola has a vertex at the origin. I also know because y is squared, it's going to open left or right. And because everything here is positive, because P is positive, it's going to open to the right. So I know then that my focus is going to be here at 3, 0. Which is going to make my directrix over here at x equals negative 3. And there's my directrix, x equals negative 3. Now, right now, all I have are these points and this line, and I'm not really sure where I'm going to sketch my parabola. I don't know how wide my parabola is. Maybe my parabola is really wide, or maybe it's narrower. Okay, but right now, the way it is, I can't tell. But we do have something that we can use to figure that out, and that's this right here. This value here is going to help us out. Now this is going to sound kind of derogatory when I say it, and I always chuckle when I say it because it sounds kind of funny, but it will help you remember. The distance from your focus, there's a line segment that connects the parabola, the two sides of the parabola, and passes through the focus, and that's called your lattice rectum. I know it sounds funny, but that's what it's called. Lattice rectum. Okay, and the lattice rectum is equal to 4p. So I always say lattice rectum is for p, which sounds really funny and sounds kind of derogatory, and I'm laughing to myself. Hopefully you're laughing over there too, but that might help you remember. And all that means is this, is that this line segment is going to be 12 units long. So I'm going to go 6 units on either side of my focus. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this right here, this line segment that passes through my focus and connects both sides of my parabola, that is the lattice rectum. And that is 4p. Okay? And so you now have 3 points, and so now you can generate your parabola. So you have these points, and you know that your parabola is going to go this way and come through this way. Okay, so that's what you're going to need to generate the rest of the parabola. You're going to need to find the lattice rectum. Okay, so we'll go ahead and do another example. Here we have x squared is equal to negative 8y. Okay, x squared is equal to negative 8y. So if I go ahead and put it in general form, the x squared is equal to 4py, which means that 4p is equal to negative 8, which means that p is equal to negative 2. Now, because x is squared, it's going to open up or down, but because p is negative, I know I'm going to be opening down. So my vertex is still at the origin. My focus is down here at negative 2, and then my directrix is up here at positive 2. So by is equal to 2. Okay, and now remember that we can find the rest of what we need by using I'll do it in pink this time, by using 4p is equal to negative 8. Now don't let the fact that that's negative in this problem mess you up, because really when we're talking about the lattice rectum, we're talking about a distance, so we're just going to use the positive 4p value. So 4p is 8, meaning we're going to go 4 units on either side of the focus. So 1, 2, 3, 4. 1, 2, 3, 4. Right? That gives you a total lattice rectum length of 8. The lattice rectum is 4p. So that's this distance right here. And then we can go ahead and sketch in our parabola. And you don't need any other points. That's all that we really need. Okay, so that's pretty straightforward. Let's go through a few problems where we're not actually graphing, we're just finding the standard form of the equation. So in this problem, it says find the standard form of the equation of the parabola with focus 5, 0, and directrix x equals -5. So the standard form of the equation, because my focus is along the x-axis, that means it's going to open left or right, which means it's going to be y squared is equal to 4px. So the first thing you need to identify is whether it's opening up or down versus left or right to figure out which form of the equation you're going to be using. Okay, now I know it's going to be opening to the right because my focus is positive and my directrix here is negative. Now my p-value, remember p is the distance from your vertex to your focus, and so that p-value is going to be 5. So I know that this equation is y squared is equal to 4 times 5x. So the general form of this equation is just y squared is equal to 20x. Okay. And the last two problems, this one it says find the equation with a focus at 0, 8. Okay, so now I know that my focus is along my y-axis, and because it's on the positive side, my parabola opens up, which means that I'm using x squared is equal to 4py. I also know here that p is equal to 8, so I end up with x squared is equal to 4 times 8y, and so x squared is just 32y. And the last one here, find the standard form of the equation with focus at -12, 0, and directrix at 12. So now my p-value here is negative, so I know I'm opening which way? Well, I know that the focus is along the x-axis, so I know that I have y squared is equal to 4py, but I also know that p is negative, and p is going to be -12. So I have y squared is equal to 4 times -12 times y, so, oh, excuse me, times x. Sorry, that was supposed to be an x there. Got a little ahead of myself. That's an x, and that's an x. And so I end up with y squared is equal to -48x. Okay, so that's pretty much everything when you're dealing with parabola centered at the origin. Next time we will talk about when we are translating the parabola where it has a vertex at hk. Thanks everybody. See you next time. Bye-bye.